Welcome to iLecture Online, and here's one of those iconic equations in thermodynamics. It doesn't look like much from a distance, but it's a very important equation. And this equation says the following. Now, of course, you need to understand what these variables mean, but U means internal energy of the gas, Q means heat, and W means work. So what this really says in words is that the internal energy of a gas is equal to the heat added to the gas, or let me take that back. What I really meant to say is the change in the internal energy of the gas is equal to the heat added to the gas minus the work done by the gas. And the prepositions in the sentence are really important. So let me say it again very carefully. The change in the internal energy of the gas is equal to the heat added to the gas minus the work done by the gas. And so if I want to illustrate that graphically, let's just say that here we have a container of gas. It has a certain amount of internal energy, and so that energy is now going to change. There's going to be a delta. And of course, if we add heat to the gas, so plus Q, we're adding heat to the gas, then you would assume, of course, that the internal energy of the gas will also increase. If you add 100 joules of heat to the gas, you expect internal energy to increase by 100 joules. But at the same time, if the gas expands, the gas is also going to do work. And so it's going to then expel energy in order to do work. And so simply, what the equation then says is that the change in the internal energy of that gas is simply equal to however much heat you add to it minus how much of energy you use to actually do work. So it's simply heat added to the gas minus the work done by the gas. Now, if you add more heat to the gas than the gas does work, the internal energy will go up. If the gas does more work than the heat that's added to the gas, then the internal energy of the gas will actually go down. Even though heat was added, more energy was expelled because more work was done. This equation is an extremely important equation that we're going to use a lot in the next several dozen videos, talking about all the various ways in which the gas can change from one state to another, how it can do work, how work can be done on the gas, and so forth. There's various thermodynamic processes that involve all the various equations of state and all the various variables of the equations of state. So keep this in mind. This may be very simplistic, but it's extremely important. Let me explain to you numerically. Let's say that we add 500 joules of energy, so let me write it down like this. So 500 joules of heat are added to the gas, and let's say that we're doing 200 joules of work. How much will the internal energy change? And so since we're adding heat to the gas, that is a plus 500 joules, and then we're doing work, the work is done by the gas, so it's minus 200 joules, and so the change in internal energy would be 300 joules. So very simple, very straightforward. If you have this concept, that's a big one. And now let's see how we apply it in the next number of videos coming up.